Assalamu alaikum. This is Kamrul Hassan, lecturer, Department of Mathematics, Milestone College. My dear student, I hope you are fine. Our today's topic MCQ part, which is chapter number 9. First of all, I want to discuss about some short techniques. My dear students, look at the board. Here, this type of maths, we can solve it within 5 seconds. How is it possible? Let's have a look. Highest degree of x variable of numerator, here n means numerator, and highest degree of x variable of denominator, here d means denominator. Look at this. Here, when n is greater than d, then our answer will be infinity. And another one, when n is less than d, then our answer will be 0. And here, when n equals to d, then our answer will be here coefficient of highest degree of x variable of x variable by coefficient of highest degree of x variable of numerator and here of denominator. And look at this here. Look at this. For this math we can apply this formula. Here, highest power of x is 4, and here highest power of x variable of denominator here 4 here. So look at this, here 4 is greater than 2, so our answer will be infinity. And second question is here highest power of x variable of numerator here 1, and highest power of x variable of denominator here 2, so 1 less than 2, so our answer will be 0. And here look at this, highest power of x variable of numerator and highest power of x variable of denominator are equal, so our answer will be this one by this one. Here our answer minus 7 by 5. But one thing is very important for this type of math. Here look at this, limiting value is x tends to infinity. Here limiting value is x tends to infinity. Here limiting value is x tends to infinity. This limiting value mandatory for this type of math. Now short technique number 2. Here, when limit x tends to 0, cos ax minus cos bx by x square, then we will apply this formula, b square minus a square by 2. But one thing is very important for you, when x tends to 0 and operator is cos, and here denominator is x square, then you can apply this formula. Here suppose limit x tends to 0, cos 2x minus cos 4x by x square, so this formula is applicable for this math. Here suppose here 4 is b and 2 is a, so our answer will be b square minus a square by 2, that means 16 minus 4 by 2. Here our answer 16 minus 4, it will be 12 by 2, so our answer is 6. So here we can write 6. And here question number 2, if limit x tends to 0, sin ax minus sin bx by sin cx minus sin dx, then we can use this formula. So our answer for this math will be, look at this, here A is 8 and B is 3, and here 5 is C and 2 is D. So we can apply this formula, A minus B, that means 8 minus 3 by 5 minus 2. So our answer 5 by 3. This is the answer of question number 2. But one thing is important, here x tends to 0 and operator must be sign, then we will apply this formula. And another one, here limit x tends to 0, cos ax minus cos bx by cos cx minus cos dx. Here our formula will be b square minus a square by d square minus c square. So here question number 3, limit x tends to 0, cos 7x minus cos 9x and cos 3x minus cos 5x. So this formula is applicable for this math. Here suppose 7 is A and 9 is B and 3 is C and 5 is D. So our calculation will be, here formula is b square minus a square by d square minus c square. So answer will be 9 square minus 7 square by 5 square minus 3 square. So we can write 81 minus 49 by 25 minus 9. That's why it will be 32 by 16. That means 2. So our answer must be 2. But one thing is important, operator must be cos and limiting value must be x tends to 0. That's why we can apply this formula. Now short technique number 3. Here when limit x tends to infinity, here a to the power x minus a to the power minus x by a to the power x plus a to the power minus x. Then we can write here our answer will be coefficient of a to the power x of numerator and coefficient of a to the power x of denominator. So have a look here. For this type of math, our answer will be, look at this here. Coefficient of 5 to the power x is 1 and here coefficient of 5 to the power x of denominator is 1. So our answer will be 1. Now shortcut technique 4. For this type of math we can apply this formula a square minus 2b here. But one thing is important, operator must be cos and limiting value must be x tends to 0. That's why here limit x tends to 0, 1 minus cos 7x by 3x square. For this type of math we can apply this formula. So our answer will be, here look at this. Suppose here 7 is A and 3 is B. 7 is A and 3 is B. So our answer will be, here A square. A square means 7 square and 2B. 2B means 2 into 3. So our answer will be 49 by 6. 49 by 6. Now shortcut technique number 5. Here when limit x tends to 0, 1 plus ax to the power b by x, then our answer will be e to the power ab. Here a means coefficient of x and b means coefficient of 1 by x. B means coefficient of 1 by x. And here question number 2, limit when limit x tends to infinity, 1 plus a by x to the into whole to the power bx. Then our answer will be e to the power ab. Here a means coefficient of 1 by x into b means coefficient of x. But one thing is important here. Look at this. When a by x, then our limiting value will be x tends to infinity, and when ax, then our limiting value must be x tends to 0. So question number 1 here our answer will be, look at this here, 5 into 3, that means e to the power 15. And question number 2 here, e to the power coefficient of 1 by x, that means 3 into coefficient of x means 5. So our answer will be e to the power 15. Now shortcut technique 6. When limit x tends to 0, square root a plus bx minus square root a plus dx by x. But one thing is important here, x variable, here x variable must be same, and limiting value must be x tends to 0. Then you can apply this formula, b minus d by 2 square root a. Here look at this. For this type of math, limit x tends to 0, square root 1 plus 3x minus square root 1 minus 4x by x. So now we can apply this formula on this math. So our answer will be here, suppose 3 means b and 1 is a, here 1 is a, and here minus 4, here 4 minus 4 is d, so our answer will be b minus d, that means 3 minus of formula, here d means minus 4, so here minus 4, and here 2 root over a, that means 2 into root over a means 1, that means we can write here 3 plus 4 by 2 into 1, so our answer 7 by 2. Now shortcut technique 7. Here ddx of a into f of x plus b by c into f of x plus d. For this type of math we can apply this formula. Here a means coefficient of f of x, b means constant, and c means coefficient of f of x, and d is constant. So here determinant of the coefficient and constant is here, and f prime of x means first derivative of f of x by c into f of x plus d whole square. So for this type of math we can apply this formula. Look at this here root over x plus 1 by root over x minus 1, so root over x minus 1 whole square, and here coefficient of root over x is 1 and here minus 1, so cross multiplication it will be minus 1, and here coefficient of root over x is 1 and this 1, after multiplication it will be 1 and formulas minus, so we can write minus 1, and here root over x, first derivative of root over x, it will be 1 by 2 root over x, so our answer will be root over x minus 1 whole square, here minus 2 into 1 by root over x into 2, so 2 and 2 will be cancelled. Our answer will be minus 1 by 2 root over x minus 1 whole square. This is the answer of first question. And now this question. And now for this question and question number 2. Here ddx of 1 minus tan x by 1 plus tan x. So we can write this type of math like this way, minus minus 10x, it comes first, minus 10x, and here plus 1. Okay, here 10x, it comes first, and here plus 1. And now calculation. So our answer will be minus 1 is the coefficient of 10x, so minus 1 into plus 1, it will be minus 1, and here plus 1 into plus 1, it will be 1, and formulas minus, so minus 1 minus 1 minus 1 into first derivative of 10x, it will be sec square x, and here denominator will be 1 plus 10x whole square. So our answer must be minus 2 sec square x by 1 plus 10x whole square. This is the answer of question number 2. And last one. And last one here, ddx of 1 plus sin x by 1 minus 10x. But one thing is important for this type of math, operator, this operator and this operator must be same. Then you can apply this formula. So our answer, it will be ddx of, we can rearrange it, sin x plus 1, here minus sin x plus 1. So our answer here 1 into 1, that means 1, and here 1 and minus 1, it must be minus 1, and formulas minus, so it will be plus 1, and here first derivative of sin x, it will be cos x, and here 1 minus sin x whole square. So our answer 2 cos x by 1 minus sin x whole square. This is the answer of math. Now look at this. Here y equals to e to the power x into sin x, then ddx of y equals to what? Look at this here. Here y equals to e to the power x into sin x. Now differentiating with respect to x, we get ddx of y equals to ddx of e to the power x into sin x. Now here we can apply that UV formula. So here after this line, ddx of y equals to e to the power x into ddx of sin x plus sin x into ddx of e to the power x. Here after this line, ddx of y, here look at this, ddx of sin x. All we know that the formula of ddx of sin x is cos x. So here e to the power x into cos x, and here plus sin x into, and ddx of e to the power x, it must be e to the power x, and here we can take common e to the power x from these two parts. So our answer will be e to the power x cos x plus sin x. So our answer is option number C. E to the power x into sin x plus cos x. Now another question. Here, if y equals to e to the power root over x, then ddx of y equals to what? Here we can solve it by this way. Here y equals to e to the power root over x, and here differentiating with respect to x, we get ddx of y equals to ddx of e to the power root over x. Here ddx of y equals to, all we know that the formula of ddx of e to the power x is e to the power x here, so we can write e to the power root over x, and again differentiating with respect to x for this part, so ddx of root over x. Here after this line we can write ddx of y equals to e to the power root over x, and here ddx of root over x, it will be 1 by 2 root over x. So our answer e to the power root over x by 2 root over x. Here e to the power root over x into 1 by 2 root over x. So our answer must be option number B. Now if y equals to ln cos x degree, then ddx of y equals to what? We can solve it here. Look at this, y equals to ln cos x degree, and all we know that 1 degree equals to pi by 80 radian, pi by 80 radian. That's why x degree equals to pi x by 180 radian. Okay, that's why we can write here ln cos pi x by 180. Now differentiating with respect to x, and we get ddx of y equals to ddx of ln cos pi x by 180, and here after this line it will be ddx of y equals to, here look at this, all we know that the derivative of ln x is 1 by x, so it will be 1 by cos pi x by 180, and here this part, and again derivative of cos pi x by 180, and here after this line we can write, and all we know that the ddx of cos x is minus sin x, that's why we can write here minus sin pi x by 180, and here cos pi x by 180, and here for this part again ddx of pi x by 180. So our answer must be here minus ddx of pi x by 180, it's pi 180, so we can write pi by 180, and here sin pi x by 180 cos pi x by 180, so it will be 10 pi x by 180, and here but there is no pi x by 180, so it's minus pi 180 into 10 x degree. So our answer is option number D. Option number D. Now another question. Here if y equals to tan inverse square root 1 minus cos theta by 1 plus cos theta, then ddx of y equals to what? Look at this, here y equals to tan inverse square root 1 minus cos theta by 1 plus cos theta, and here we know that the formula of 1 minus cos 2 theta equals to 2 sine square theta, and another one is 1 plus cos 2 theta, it's 2 cos square theta. So that's why we can apply this formula here. tan inverse here 1 minus cos theta. So H2 sine square theta by 2, and another is 1 plus cos theta, so it's 2 cos square theta by 2, and here 2 and 2 will be cancelled, and here square root square and this square will be cancelled, so we can write y equals to tan inverse, here it will be tan theta by 2, and we know that the formula of tan inverse into tan pi by 2, so it's theta by 2. Now derivative with respect to theta, we get ddx of y equals to ddx of 1 by 2 into theta. So that's why our answer must be 1 by 2. Here this option is correct answer. Now another question. If y equals to x to the power ln x, then what is the value of x by y into ddx of y? Here, look at this. Here y equals to x to the power ln x, and now taking ln on both sides, here for this part it's come first, so ln y equals to ln x into ln x, so we can write ln y equals to ln x whole square, and now differentiating with respect to x, we get here ddx of ln y equals to ddx of ln x whole square. Here for this part ln y, so it will be 1 by y into ddx of y, and this part here. Now we can apply this formula. Here we know that ddx of x to the power n equals to n into x to the power n minus 1. So this formula apply. Now applying this formula on this term, so it will be 2 ln x into ddx of ln x here. So we can write 2 ln x into, for this part ddx of ln x, it's 1 by x. So our answer x by y equals to 2 ln x. Look at this. Here x by y into ddx of y equals to 2 ln x. So our answer will be option number C. Now another question. If y to the power x equals to x to the power y, then the value of ddx of y will be here y to the power x equals to x to the power y. Now taking ln on both sides, here look at this, ln x to the power y, so it come first, and here ln y to the power x, it's come first, so x ln y equals to y ln x. Now differentiating with respect to x, we get here ddx of x ln y equals to ddx of y ln x. Now we can apply UV formula, so it will be x ddx of ln y plus ln y into ddx of x. And for this part, same procedure, we can write y into ddx of ln x plus ln x into ddx of y. Now after calculation, it will be here x into 1 by y into ddx of y, and here plus ddx of x is 1, so it will be ln y. And here for this part we can write y into 1 by x, and for this part it's plus ln x into ddx of y. Now after this line, we can write here x by y into ddx of y plus ln y equals to y by x plus ln x into dy by dx. Now side change, so it will be x by y ddx of y minus ln x into ddx of y equals to y by x minus ln y. Now we can take common from these two parts, so ddx of x by y minus ln x equals to y by x minus ln y. So our answer will be, therefore ddx of y equals to y by x minus ln y by x by y minus ln x. Now after this line, we can write here minus ln y minus y by x, and here minus ln x minus x by y. So after calculation, our answer will be ln y minus y by x and ln x minus x by y. So our answer, option number C. Option number C. My dear student, this is our today's lecture. No more today. See you again in the next class.